So let's come over now and learn how to use the calculator to enter the set of data, enter a set of data, and then let the calculator generate the line of best fit for us. And before I do that, there is a handout. I want to make sure I get it up here on the viewing screen so that it'll be on the DVD. And this is the first part of the handout, and then I'll move that in a second. Back in the control room, does that look like that would be readable on a DVD? Okay, I need to bring it up a little bit. Okay, so I want to make sure this is going to be readable, so let me see if I can do this. Let me back up just a touch. Shoot. How about that? Is that okay? All right, good. Okay, I want to make sure that people, and it doesn't quite catch all the writing there, but very close. Okay. To find the equation of best fit, these would be the calculator steps you would take with like a TI-83 or an 84 calculator. The actual commands on the calculator on other types of graphing calculators would be similar but somewhat different on different type of calculator. So what you're going to do is you're going to go to the y equals key. You're going to either turn off any equations, and I'll show you how to do that today, or you will disappear them, erase them. Then you'll go to your statistics set and you will enter data into what are called data lists. And we'll be entering data into L1 and L2. And then there's a series of commands here, and what I'll do is I'll walk you through this. But if this is readable on the DVD, then somebody could pause the DVD and write these things down. Let me just go ahead and for completeness and move down here so that the second step would be shown. Here it is, step 2. And we'll go over this in a minute. And what I want to just point out to you in the second step is over here on the right, here's linear regression right here, and we're going to be doing that today. But notice, and tomorrow or the next class session, we'll be doing some of these others. So there's all these different options available for generating lines of best fit or curves of best fit. This is that series of commands. And then finally, step 3 is to then take graphing your scatter plot and then being able to get that curve or line of best fit to actually lay on top of your scatter plot. So these are the commands for that. Move that over a touch. Okay, and I passed this out to everybody. So everybody should have a copy of this handout. Yes, they're up here. Okay, so now using the graphing calculator, and I will back up a tad here. I think that actually is pretty good. There we go. Okay, I'm going to go ahead just for interest's sake and follow the steps that are on that sheet I just showed you. So what we do is we turn our calculator on. We go to y equals, and let's say that I did not want to erase this particular function, but the instructions said turn this thing off. The way you can turn off a function without erasing it is you can move over onto the equal key and hit enter. Notice the cursor, notice the black darkened equal sign. If I hit enter, the equal sign looks differently now. See? So that function's still there, but it's turned off. It's turned off. All right? Next step. It says go to the stat set. Now, I just hit the stat key, which is right near our blue arrow keys. What the command said to do is to go into edit. Now what I want to do is I want to show you something. When I go to edit, there's probably some data there from some work I've done previously. And when you play with these things, same kind of thing will happen. There's probably some data. Notice I have a bunch of data there. Okay? Let me show you how to clear a data set first. So go back to Stat, and then notice item number 4, clear list. So I go to item 4, and now on my keys numbered 1 through 6, I see on the case of the calculator L1 through L6, on the numbers 1 through 6. So what I can do is I noticed I had data in L1, 2, and 3. So I can go shift or second L1, comma key is above the set number 7 key, and then L2, comma, and then L3. Okay, so I can specify a series of several lists at one time, and if I hit enter now, it tells me I'm done. Now I go back to Stat, select item 1 for edit, and notice the lists are empty. Now, it's real easy, and you'll be real fast at this real soon with a little bit of practice. We can now enter the data into our L1 list. So we're going to go -10, -5, 0, 5, 10. I think those were the numbers in our problem, weren't they? And then I arrow to the right. Now I need to make sure that I put in exactly the same number of items in both lists. Everybody hear that? I need to make sure I put the exact same number of items in each list. Otherwise, if I try to do something with this, it'll give me what's called a dimension mismatch. If you ever see that error message, DIM mismatch, that means that you have data that's not equal in number in each set. So this set of data was 0, 1, 4, 9, 16. 0, 1, 4, 9, 16. Everything's good. Data is in the memory of the calculator now. Quit. Let me show you something. If you want to check this back on this home screen, I just hit quit.
How did you quit? Oh, there it is.
It's shifted on the mode key right there near the top of your calculator. So I got back to the home screen. And if I want to see what's in the L1 list, all I have to do is go Shift L1, and here's that set of data. I could go Shift L2, and here's that other set of data. So I could spot check to make sure I entered my data correctly. Okay. Next step, we'll just follow what they told us to do, is we now go Stat Plot. Now, Stat Plot is on your Y equals key. So we go Shift Stat Plot on your Y equals key. And now what we want to do is we want to turn one of these on. The calculator has a capability of plotting 3 statistics plots at the same time. So we're going to go to item number 1 just to turn this guy on. We hit enter, which now activates plot 1. And we step down, and this is a scatter plot, this first one, and that's the one we'll want. What this one would do is it will take the data points on your scatter diagram like we drew by hand, and it will connect the data points with straight lines, similar to what I did on the board. This is kind of a bar graph, sort of a frequency diagram, and then these things are called bar and whisker. Something, I think that's what they're called in statistics. Then we have, I'm going to go ahead and hit enter right there. And notice now the default settings down here, I could choose, I could use the L1 to L6 to pair up my data for my X data set and my Y data set. So if I had my X data maybe in L3 and my Y data in L5, I could set it up by just choosing those commands there. But it's already, the default setting is this. And then down here, so these are all good. Everything's looking good. And I hit enter here for my scatter diagram. And then down here, this is going to leave little square boxes. little plus signs or just a pixel dot. The pixel dot's not very good. It's so tiny. I usually use the box. So this is all set. So I now quit. And so if I go to y equals, notice something on the y equals screen. This polynomial function is turned off. As I mentioned earlier, it's off. But notice up top. Now you're going to have issues with your calculator on this kind of thing, and I answer this question all the time with people. They come in, my calculator isn't drawing my picture, and they're doing some kind of function thing. But what happened somehow is they got up here, and that thing's dark, and they're really not doing a scatter diagram at all. Okay? So if you see one of those darkened, that means they're turned on. Okay, so we have stat plot turned on. Now what would be the next thing for graphing that you normally would do? Viewing window, right? Your left and your right and your bottom and your top. So we know what our data looks like, and so what I would do now is go to my window and set up an intelligent window. So I know my data was over at -10, so I'm going to go -15 just for the fun of it. And how far to the right did we go? +10? So let's go to 15 there, and why don't we put tick marks every 5? And vertically, our y data, it went down as low as, how low was our y data? 0. So I'm going to go down below that a ways. Why don't I say -5, and let's go up as high as 20 and put tick marks every 5. So I just want to make sure that I'm lower than the data and higher than the data. And now I'm going to hit graph. You're going to love this. This is much better than doing it by hand. Boom. Isn't that neat? If you turn trace on now, turn trace on, and look at what it labels. Up here at the top, it tells you that you're doing a stat plot. It's called labeled P1, and the data set is L1 and L2 being used. Really cool. And down here, look at this. It puts you right on your first data point in your set, down here on the bottom. Okay? And so we can move our arrow, we can take our right arrow key, and look at the way it jumps from one data point to the next. And nowhere in between. Right? Nowhere in between. It only allows us on a scatter diagram to be right on that data. Okay, here's where the fun part comes. I could come back here now, and I'm going to clear this polynomial out of here, and I'm going to put my guess, or our guess, in there.
Now, did that really go away this time?
I erased it.
Okay.
I just hit the clear key to get rid of that Y1 thing.
Because you had it off, could you have left it on there and
Sure.
just done it on Y2?
Yeah, sure. Could have. So what I want to do here is I want to take my mental guess, my rough sketch on that whiteboard. I guess the slope was 0.8, right? 0.8x, or 4/5 times x, plus eyeballed it at a 6, didn't I? And if I go graph, it comes in there pretty much like that line I drew on the board. Okay? However, what's going to be asked in your book and on test and in Math XL is, what's the equation for the line of best fit? They want the calculator to do some adjusting, folks, and to minimize the differences between these values, between what the guess line is going to be, and so it wants to get something probably more accurate than me just eyeballing it. All right? So let's let the calculator do it, and what I'm going to do is I'm going to leave this one in the memory. I'm going to leave that sitting right there because I'm curious to see how good we are with this guess. So here's how we do it. Quit, come back on your home screen. Ready, back on the home screen? Okay. Let's let the calculator generate a linear regression equation for us. So here's how we do it. We go back to stat now, and look at this menu set. Right here doesn't look like it's too good. This means sort data in ascending order, assorted in descending order, clearing the list we talk about, and don't worry about that last one. But look across the top. This looks like it might be a good spot to go to. Calculate. So I arrow to the right, and it brings up, oh, this is kind of neat. We're doing kind of two variable statistics, but look at this, linear regression. What's the slope in this equation right here? What's the slope, folks? Letter A. Letter A. What's the y-intercept? Letter B. What do you think this means? Where the pencil's pointing. Quadratic regression. Generate a quadratic function. Now, actually, that data probably would be better doing a quadratic model, wouldn't it? The way we looked at, I mean, we saw the sketch kind of curving like a parabola. So that probably be a little better one. Cubic. This is not like a quart of milk, folks. This means quartic. This means fourth degree polynomial. And I want to show you something. Let's go down here further. See that arrow on the number 7 there? That means there's more stuff down below. Oh, here's another linear regression model. What's the slope on this one? B. What's the y-intercept? A. Okay? See? It. The thing that's multiplied times x is your slope. Okay. Keep on going. This is natural log regression. Later in the course, we'll see these things. Exponential regression. Power regression.
Does regression just mean make us an equation?
Yeah, just think of it at this point, until you take a statistics course, think of it as your line of best fit, or your curve of best fit. So there's all these different ones built into the memory of the calculator, and then it uses statistical methods to generate the best one for you. So we're going to go back up to the top and come down here and select item number 4. So I hit that, and then I specify the two lists we want. It will understand L1 and L2 if I don't do anything right now. It'll understand if I hit enter, it'll treat L1 as X, L2 as Y. If you're using any other list, you want to put the names of the list with a comma separating them there. In other words, example, L1, comma, L2. Now I hit enter, and it does all the work for us. Watch. Oh, that's exciting. Wow.
You were right.
Man. I did not
You know everything.
I did not do this. I did not do this problem ahead of time. Okay?
You're just that good.
Yeah, I've just been doing this for so long, I guess. Okay. So anyway, it happened to nail it. I didn't expect that to be the case. Okay, now, what we would want to be able to do is we want to be able to take this equation without having, this is simple. I didn't expect this at all. Okay? So normally what you would do is you would normally want to write this down on your paper. Y equals 0.8x plus 6, right? As your regression model. So what you then do, normally these numbers are not going to be near this nice. So to get the calculator to actually store it for you, you come to an empty spot, like Y2 or any of these others down here, empty spot, and watch this. Let's see if this is, yes, it is on that handout that I gave you. What you do is you come to an empty spot, and you want the calculator to automatically stuff the regression equation into this Y2 location, automatically. And the way you do it is you go to variables key, which is over near your blue arrows. You hit variables, and VARS, V-A-R-S is the abbreviation on the key. And then item number 5 down here is statistics. And there's some weird looking symbols here. I'll tell you what a couple of these items are. This is the number of items in your list. This is the average value of those items in X. This is the sum of the X values. This is what's called the standard deviation on the X values. This is the average value of the Y's. This is the sum of the y's and the standard deviation on the y's. So someday, some of you may have already taken a statistics class, so that's the reason I mentioned those. What we want to do is go over here to equation. Ah, there it is, hiding in this menu right here. There's our regression equation. And so what we do, we were in y equals, remember? Everybody remember, we were in the y equals in an empty spot, and what I do is I get to this location and I hit number 1, and boom, it stuffs it in there for us. It stuffs it in there for us. All right? And I hit graph, and this is boring because it fit exactly what my guess was earlier, right? Okay, and it lays it right on there. Now when you turn trace on, folks, you can now arrow down with your blue arrow key, and it jumps onto your other functions. Here was our guess function, y1. If I go to y2, there's my regression equation. When I'm on y2 in the trace mode, I can now move across that in between the data points. Here's some vocabulary. How many of you will be taking chemistry? A bunch of you. How many will be taking some business classes? Another bunch of you, okay? So you're going to hear this kind of vocabulary frequently in these different areas of science, business, and so forth. And so what we can do is go between data points, folks. We can go between data points, and that's called interpolation. Interpolation, going in between data points, interpolating. We used to have to do that by hand. Now we've got these fancy calculators that'll do it for us. So if I said I was at 2.5 with this line of best fit, my guess on the y value would be 8 if I was at 2.5. What if I was outside the data set, say up over here at maybe around 13? 13. I would be extrapolating. I would be going outside the data set to the right, outside the domain of the data set, and I'm extrapolating using that linear model. A guess of the behavior at 13 is 16.4. Okay? Interpolating goes between data points. Extrapolating is outside data points. Okay. What if, let me clear those two functions out and keep my data set. Watch this. I want to show you something else really neat with the calculator. Let's say I want to alter that data set. I only want to alter one data point. Two ways of doing it. I could go to stat. I could go into edit and come down there and change one of the numbers. I want to show you another way to do this. Let's say instead of being a value of 9 when I'm at 5, I want to be in L2, I want that value to be 12. I want that value to be 12. Okay? In L2. Okay? So that's element number 4 in L2, isn't it? Okay. Let's see if the calculator understands this. I want that value to be 12. And I want to use the store key, which is down next to your on key, just above your on key, store. And then what I'm going to do is I'm going to now punch L2 in parentheses. I want that to be element number 4. Now, if I graph, there's that 12, folks, in the data set. And if I ran the regression thing real quickly, item number 4, there's the equation. Look at the way the slope changed and the y-intercept changed. See that? Okay. So you can make adjustments to the data. You can come up with a new regression equation pretty easily. Okay, I think that wraps things up for today. Linear behavior. Next session, we'll start playing with quadratic behavior, and that'll be tomorrow, right here.